bitte. Neben das Mikro.
Mikro?
Für die Aufnahme.
Okay. Doch zu leise. Okay. My name is Markus Mann. I'm a senior consultant at ISC Solutions, a relatively small company. My job there is normally I consult or help our customers with J2E or Java Enterprise architectures, and we, besides of this traditional business, as I would call it, we have for our customers in the insurance and energy industry, we also provide something we call innovation consulting, where we try to help them move their business into the digitized world, where many things are happening, as Christian said before, and that's also the main reason why we are interested in showcases and live demos, because we really have in the insurance industry is not known as the innovativest of industries, and we need to have solutions or need to have showcases where we can just show them and make them feel how this topic works, and that's how we got in contact with Christian's company.
Yeah, so basically the idea for the whole showcase is driven from Markus' side, because he has the contacts to the insurance companies, and we work together on this project in order to integrate with MQTT and other technologies, and to make it a fully fledged showcase from an end-to-end solution from a smart home to external applications like mobile app and other stuff. So that's basically why we are here together on the stage, and what we're talking about today is basically we will quickly give an introduction why smoke detectors are very important in every home. Then we will quickly move to a live demonstration, because I think that's why you are all here, to see something happening. And then we will discuss quickly which technology is involved in there, and then let's do a quick outlook and lessons learned we learned in the process of developing this showcase. So now we'll hand over to Markus again.
Yeah, and I get myself wired.
Okay.
Okay. So basically, we in our topic title we have the topic fire detection and break-in detection. That's basically how we came into this whole topic. And fires are really life-threatening dangers. So fires are one of the dangers at home. And there are 2,000 fires every year in Germany, taking more than 400 deaths, 4,000 partly heavily injured people, and also €1 billion of damages in private property. So it's really a big danger in home, and also where there's fire, there's smoke. So normally the saying goes, where there's smoke, there's fire. The real danger in this case is in fact the smoke. So most people are not injured by the fire themselves itself, but are injured by smoke. So Actually, if you, I did some research, and there are people saying that 3 breaths can be sufficient to die. So it's a very toxic cocktail of gases. And even I read about one story where even 1 breath had lifelong consequences. So smoke is really the danger here. Normally, you would say if there's smoke, then you can smell the fire. The problem is 70% of fires start at night, where the human sense of smell is inactive or switched off, so you don't really notice that there's a fire. That's a great danger. And that's where also those little friends are quite handy, come in quite handy. And signal, if there's smoke, signal that there's a fire, and you can effectively save lives by helping you to get out in time. So how much time is there? So I also did some research, and people say that you got 4 minutes to leave the house when counting when the fire started. So after the first spark, 4 minutes. The problem with that is 2 to 4 minutes, in fact. So the problem with that is the smoke detector normal smoke detectors should signal after about 2 minutes, because there's sufficient amount of smoke then. And this leaves you with 2 minutes to get out. So if you ever hear a smoke detector at night and smell smoke, then just get out as quickly as you can. So, and that's also a main reason why those things starting to get mandatory. So in USA they are mandatory right now. In France and in Germany they will get mandatory. In Germany it's 2018. There are some states in Germany where they're in fact already mandatory, and also for not only for new buildings but also for property you have. So if you own a flat or a small house or a house, then you will have to think about smoke detectors at latest 2018. And most people, when they think about smoke detectors, so I don't know, can you raise your hand if you have a smoke detector installed? Wow, very cool. In the year 2000, I think in Germany there was 2% of the population who had a smoke detector, and now it's around 40. So I think it should be more than 40 years. So in the states where there are more laws in effect, or the laws are in effect, those numbers rise up to 80, 85. And so in 2018 in Germany, people will start to really buy smoke detectors. I could also ask who has a smoke detector at home but it's not installed, or a battery is low, but I leave this. So actually in 2018 everyone will choose between the simplest solution available, cheap, go to the market and just buy one. And there is also room for advanced solutions. And especially in the smart home context, we try to explore and try to find out, because our customers in the insurance industry are actively searching or interested in solutions for home security. Normally the insurance business is they pay if there's damage on your house, and what the opportunity for them would be is to actively get you a secure solution which has some extra features. And we were starting to think, in the smart home context, what could those features be? So we came up with some ideas for improvements, maintenance, battery status, connectivity, just to find out the state of the solution, and also improve security so that the solution itself can come to a point where it actively calls the fire department if there's a fire. And what we did, I usually call it a showcase, so it's not a product. So we will show you afterwards what we've done. We are not building a product, we are building a demonstration. So our objective wasn't really to get this edgy and completely high usability solution, but just to show the field to our customers, and also to evaluate available technologies that you can just go and buy and go and download, open source technologies, what's the state of the market, what can be done easily. And then also to iterate and get out or find out about the features. So showtime, I hope everything works. We have this beamer here, which you can see after I have explained you the basic architecture of our solution. So basically what we have is we have components inside of the house. We choose Homematic as just openly available standard. You could choose another standard. Then we have this home server, which we explore in detail later on. Then we have MQTT broker outside of the house. We heard about this today in the morning about MQTT. And then we have this app, which just connects to the MQTT broker. And when we have a quick look on our maintenance features, it's all in German, but I translate it to you. I hope everything can see a little. The camera can't, but what we have is we have this fire, yeah, perfect. Fire security section here. We can have a feeling about the status. We can see that everything is green. We can go into details and see that we have, in fact, 2 smoke detectors here, one for the living room, one for the sleeping room. And we can just raise the test alarm, and then we see what would be shown on the telephone when there's a test, and then actually those things should start to beep, but they don't do, which is a little bit of a concern at the moment. Okay, that didn't work. Normally those should start to beep now and find out that the configuration is okay. They don't do this yet. I will find out why when you talk, and hopefully we get to a point where it works again. So, what you can also do in the app is you can quickly call an ambulance or the firefighters if you see a fire and the smoke detectors haven't signaled yet. And for the smoke use case, for the smoke detector use case, those are normal licensed smoke detectors. So if they signal, if the communication is working, every other smoke detector will signal too. And then what also will happen is that the home server will signal via the MQTT broker, will signal the alarm, and you can also have adapters for emergency services on this HiveMQ platform, and come to a point where the ambulance or the fire department will come. I think I unwire myself. I think we really have to restart the app. I think that's the only thing we have to do. Oops.
Okay. So while Markus is trying to reset our demo and to show you the final demonstration, which is pretty much the most impressive one, because this was only a test alarm. Later on, we're showing the real fire alarm. But first of all, before that, I will just talk quickly about what's outside of the house. So basically, we heard it today from Annie Stanford Clark. MQTT is a protocol which is very lightweight and ideally used for the Internet of Things. So in this case, we use MQTT here. MQTT is based on publish subscribe. So if we, for example, have one temperature sensor that sends its data regularly on a topic called temperature, for example, then the MQTT broker, which is in the middle of the whole communication, like the dispatcher of all the messages, will send this to all subscribers. A subscriber is basically any device that has been subscribed to the MQTT broker beforehand. And yeah, that's basically how the communication works. So So in our case, one of the app is like this. The app is the subscriber, and the publisher is the home center, and then it will get over the internet and to our HiveMQ broker in the cloud, which actually here in the showcase is locally on this Raspberry Pi. Markus is showing later, but in the real showcase, it's on the internet and then goes to the app or to any other device. So maybe the question is, I will just elaborate a little bit more why we chose MQTT for that use case. So basically the most important thing is it's very lightweight. So it's bandwidth efficient. If you want to have, you have more and more devices, and it should be at most very compact and not very verbose. So this is why we didn't choose HTTP for that. Another valid point is that it has this push capability. So publish subscribe always means that you will get the values in real time. So if MQTT devices have open TCP connections, and with these open TCP connections, they can they can get the messages as they are triggered. So there's no delay in while normally you would pull some device or some server to get this data. And also you have this great thing which is called quality of service that automatically is built into the protocol and allows you to handle different guarantees of messages if the message is arriving or not. So you can just say, okay, I want to just send a message and I don't care about arriving. So I say, okay, just try to send it, and if there is some package loss or something, then it is, it will not arrive. But you can also say, I want to make sure this message arrives, and then you set this quality of service level one step higher, and then the message arrives. Yeah, another point is it works great behind a firewall. So why most of devices, like when you use HTTP, you have this problem with nothing in your home. So that's when your external device cannot just ask devices inside your home. But in the case of MQTT, the connection is, maybe I just switch to the next slide, and I can tell you a little bit more. So we have the firewall here, and so this small like home central station just connects to HiveMQ, the MQTT broker of choice, and does this connection from within the house. So there is no issue with connecting or using the device from outside the house. So in this case, it's also possible that the app from outside can publish, for example, the test alarm we just have seen, and without having to call this device directly, but which is already connected to the broker and then therefore receives this message. So basically what the MQTT architecture is here, so we have, it's pretty simple for this showcase. So we have the home central station, which publishes an alarm if there is one, publishes a regular status of the smoke detectors and a regular battery status. And also it subscribes to the test alarm, so when we click the button, as Markus just did, then we will get the test alarm signal into the home center, and then it will trigger all the smoke detectors. The same is also the app shows all the statuses which the home server is publishing, and shows that in the app. Okay, so let's just talk about HiveMQ, why we used HiveMQ in that specific case. So first, HiveMQ is a MQTT broker. It's built for high performance use cases. It's highly scalable. You can cluster it, and it also has this open plugin system. And this open plugin system is, in our view, a key point, because you can easily plug in other stuff. Like my colleague Dominic showed yesterday, it's also possible to let MQTT call your cell phone, for example, or send text messages to this stuff if you integrate it with, for example, the Twilio API. And it also supports the bridge protocol, so we can talk to other brokers, for example. And with native WebSocket support, we also have built a mobile app for a web browser to also use this live data to show the statuses. So that's pretty much what's HiveMQ at a glance, and why we used it example for this project. And You can see here the overall architecture a little bit. So we have HiveMQ in the middle for the cloud. For the cloud deployment, we have the mobile device connected via MQTT. We have another web dashboard that's connected over MQTT over WebSockets. And then we have other services or other plugins that are pluggable, which we actually are not in the showcase yet, but would be easily possible. So that's actually possible. So we can send an SMS when there is a smoke alarm. It's possible to call any other API with the HiveMQ plugin if there is a message on that topic. And also we can persist the data for future use or for historical data to see the whole overview of maybe the whole year in the smart home, what alarms happened, what was the status, when was the battery empty, to see some kind of patterns and to show this to the user. So that was basically from outside the house. So now I will give back the microphone to Markus, and he will tell us a little bit what's inside the house.
Yeah, the sweat is remarkably interesting. I think the problem is in the app. So let's see if it will work, but I'm not quite sure. I can tell you why then when we come to the architecture. So basically, let's take a moment to explain you what's exactly what we did in the house. So we have this smart home server, which is this little box, which from my perspective I think is working quite fine at the moment, which is in fact the Raspberry Pi. I think you all know what a Raspberry Pi is. What's interesting is this busware CCD, which is a component you can just get inside on the internet, which is basically something like a shield for the Raspberry Pi, which enables you to have radio on 846, I think, megahertz. And there are many smart home protocols which are using this frequency, and you can actually connect to lots of them. We have used Homematic here, which is why we have this Homematic smoke detectors, and there's also Max and some German providers, and also some international ones, which you can basically connect to via this frequency. So and what we also have is this Wi-Fi stick, which is barely visible. Those get smaller and smaller every time, which just gives us connectivity to the internet from this box. And on the software side, what we use is OpenHAB as integration platform. We will hear a little bit about this later on. And HomeGear, which is actually something like a driver. It's also open source. It's quite cool. It's like a driver for this Homematic system. And OpenHAB, I have taken this from their homepage because I think it's perfectly accurate. OpenHAB is a software for integrating different home automation systems and technologies into one single solution. So with OpenHAB, you kind of have the possibility to have a load of different plugins for different protocols and get everything in place in one integrated solution, and actually can play with a lot of technologies in this context, which is quite cool. And also from the basic architecture, it's a really simplified diagram that I have put up here. The core components of OpenHAB are currently moving to Eclipse, which is Eclipse Smart Home. So they are actively developed and are changing very rapidly. I think we've started this showcase thing about half a year ago, and it's really moving really fast. They get in many features, and there will be coming very interesting. Eclipse Smart Home will be coming very interesting. And for the other things that are built on these core components, the main easiest components are items, protocol bindings, and automation logic. And I like to go a little into detail what these are. So items, I think the real term is item providers, are basically representatives of the physical world around you. So if you, in this platform, you can define items which are mapping to real devices and also numbers or switches on these devices. So in the energy world, you would have a temperature sensor for your heating, and the number of the current value in the room will be one of these items. Currently, the temperature of the living room, for example, will be one item. So you define those things and define a model of your world, and then have those protocol bindings. There are many. We mainly use Homematic and MQTT bindings, where you can use the binding technology to bind those virtual representatives now to the real device. So you can actually configure the item to map to a channel on this device. And then actually, if you do this, it's no coding involved, it's just configuration. After you've done this, you can actually have an Eclipse dashboard where you can just switch on and off things, which is not that useful with smoke detectors, but you can map switches and sensors and just actively change the values. And what then makes the home really smart is this automation logic module, where you can actually, with some language, it's a specific language for OpenHAB, can define rules what to do if something happens. So it's basically if-then rules, where then is just a function you type. Good. So it might get loud. I doubt so, because I think the main problem at the moment is that I can't connect to the Raspberry Pi from the app. What haunts us with these things is that it's kind of a side project of us, and the app, for example, was done by a student of ours, and the Raspberry Pi thing was done by somebody else, and there are also sometimes subtle problems with that. At the moment, the problem is a little more, shows a little more. I can only tell you what should happen at the moment, so it probably won't get loud.
But for any case, we have.
For any case. Yeah, for
anybody wants to have earplugs, it can't be maybe the first row is especially on the.
For any case, so let me just tell you what we did, because basically it's something we heard today in the keynote. The main thing with the smart home platforms is that once you have ruled out the infrastructure or installed the infrastructure, you can have more use cases implemented quite easily. And most of the time, you can combine things that don't really belong together to do something really cool. And what should happen, or what we have is, we have this Homematic switch, which is not really sexy, but you can also have these installed in the light switches, so you can control the light in the room, switch it on and off. And normally in the showcase, we use this switch just to symbolize every light in every room in the house. And with that, the first thing what we did is in the smoke detection use case is just if the smoke detectors go off, all the lights will go on. So if it's at night and you want to get out, then this is quite handy. And then the next thing, this one in German says break-in detection. With this component, which you normally also use for heating, it's a door sensor. So actually it's a magnet contact, which is mounted on the door, and the other one is mounted on the frame, the other part. And if it's opened, it signals that the door is open or the window is open. Normally, for the heating, you would have the heating to go down until the window is closed again. And in our case, what we did is, if the door is opened, the lights will start to flash in the whole house. Everything is starting to flash, and all the smoke detectors will go off. So everything will be really loud, and those are really loud. And this is something normally we just show our customers to get the feeling of how this integration works with just creating new use cases. And as you've seen, it didn't get loud, so I broke in, and it didn't get loud. So unfortunately, the earplugs are not needed, but for the ending part, I will leave this to Christian. Maybe I can come up with a trick. If you smoke, normally those don't really go off if someone smokes. But if it's dense enough, then from what I think this should go off, and the light would go on. I also had a test spray with me, but they took it from me because you cannot fly with a test spray. You can fly with deodorant, and it's the same thing, but if it doesn't smell, you cannot take it with me. So unfortunately, I've lost it. Yeah.
Yeah, so sorry that the cool demonstration didn't work, because we tried it this weekend, and also we tried it many times. It always worked fine. So I'm really sorry that this is. But I think this is this is the thing with live demos. And yeah, so sorry for you guys. We will also do this again in another conference, and maybe post a video online so that you can all see what should have been happened. So that's only to say for that. So to wrap this session up, I will just go to some few steps what we could improve to bring this showcase into a production kind of scenario. So first of all, at the moment everything is wide open. So we don't use any security on the communication outside of the house. This is pretty open, and also the communication inside of the house. So there you would have need to embrace more authentication and authorization logic in order to see which devices are there and how they are interacting with MQTT broker, for example, and other devices, and to just limit that to that for each device, to say, okay, this device can only publish, for example, on that topic, and this device can only do that, and this device can only, for example, subscribe to that topic, so that there's no attacker can just read your sensible data out of your home, or just use the system and to let go of the alarm every 3 o'clock in the morning to wake you up and to maybe disturb you. So this is the big steps. And also point number 3, I think we just experienced that. So we should have used sophisticated hardware to make this more sophisticated and more proven against errors, against some, as we heard today morning from Andy, that the stuff has been waterproof if it's outside the house, for example, and other things that the hardware is sophisticated and also capable for the day-to-day life. And also some platform improvements, meaning that some additional services should be attached to this. Maybe we showed it in the overview. Emergency services could be triggered automatically. Other services, maybe your neighbors could be included in the whole system, that your neighbor will also get a fire alarm or any notification if his house is very near to your house, or your flat is above somebody else's flat, to integrate this also together, that you have a very integrated solution and not only help you but also help your community or your immediate neighborhood. And these are basically the points we see here. I think there are also many other things which are, but this one are the four big stuff we identified. And also we also have some lessons learned. So it's definitely possible with current technology to build such a smart home solution. So the technology is there. It has to be maybe refined and some on 2 edges, but in general it's possible to build such a solution. Also, as we have seen, the smart home age is really transforming rapidly. So we are going from almost no such interest about 10 or 20 years ago into now monitoring everything from our energy level, energy consumption, and any other stuff, which is mostly also you like to do it because it's cool or it's fun. So that has rapidly changed and will also change more in the future. And also, of course, it's cool to see that some things like OpenHAB involved, which is an open source technology now under the Eclipse Foundation, which is there. It's possible to use for this stuff and to just take it and just build something without coding too much. So we can just easily, like we can see here, this is the OpenHAB interface. And is it working now?
Probably. So
okay. Okay, good news.
It might in fact get loud.
So I will just end with this slide and then we will try again with the demo. So, and another thing is, of course, we always need certified components. So a smoke detector, which we have here, it's certified. So there has to be always have this integration from the certified components from manufacturer that has like a mass production, and to use these devices intelligently and integrated with other stuff, because I think it's very difficult to use devices that are not officially approved by government or other institutions. So that's the 4 biggest lessons learned we had during the project, and if then I will give it over to Markus again, and we hope that the demonstration is ready now, and you all guys, you all hear some real fire alarm action.
So if you really want to have the full experience, then you need to stay here for 1 minute. What I did is there is some out of the box dashboard in Eclipse that you can use, and I hope everything works fine now. So what we did is, when you activate the alarm, just the lights in the house will go on and off again, so you can see that the alarm is activated. And also it comes in handy because all the lights are off now, so they can go, and no lights are still on, and no lights are taking up energy. And actually, if someone wants them, it's really loud, so I would encourage you to
anybody? Okay. Oops, sorry.
Actually, the system should react. It's not that fast because the device just.
Anybody else?
And what happens now is
So, perfectly. So now just thank you for coming to our session, and I hope you have learned something new. And we also here for today, and if you have any questions, just ask them now or come to us afterwards and we will answer them. Thanks.